So part 2 here, graphing these quadratics, okay? So domain and range. It doesn't change from what you learned at the beginning of the year. What is the domain? Yeah, the x values, right? Okay? So it's the x values that satisfy the function, right? So domain is the x. What's the range? The y's. Okay? Doesn't change what we learned from the beginning of the year. Okay? Now, so the domain for all parabolas will always be all real numbers. Okay? All real numbers. So to find the range then, the range is basically what you're looking for. The range is what you have to calculate. Domain, all real numbers, always. Okay? So to find the range, again, it's all based off of how that graph is opening. Okay? Do I have a maximum value or a minimum value? Okay? So that is going to be written as an inequality here, one or the other. Y is going to be greater than or equal to some number. Y is going to be less than or equal to some number. Okay? And it's all based on if it's opening up or down. So let's take a look at this, and I think it'll make a little bit more sense here. Okay? So it says determine the function has a maximum or minimum value, state the minimum or max, and then find the domain or range. Okay? So looking at this graph, open up or down. So it opens up. Is this going to be a maximum or a minimum value? Minimum value. Now, we need to find that minimum value. How do we find it? We're finding this bottom point here, right? That vertex, right? So that's where we're starting out. X equals opposite of b over 2a, right? So opposite of b is 24, 2 times a, so 24 divided by 8 gives me 3. Okay? Now how do I find the y value for that point? Plug it back in. Okay? So plugging this back in, so 4 times 3 squared minus 24 times 3 plus 11. Okay? 3 squared is 9 times 4, 36. Again, you can just plug it in a calculator. 72. So 36 minus 72 is negative 36. Negative 36 plus 11 is going to be negative 25. So negative 25 is my y. So my vertex is 3, negative 25. Okay? Now, domain, what's the domain?
3.
All real numbers. Okay? Because again, it's always all real numbers, right?
How's it not 30?
Now, what's the range? Because I can put any number in there and get a value out, right? That's what they're talking about with domain. What x's can I put in and get a number out? Now, what's the range? So to calculate the range then, it's the y values, right? Again, this point is 3, negative 25, and I'm going up, right? So these numbers are all bigger than negative 25, right? Make sense? So it's y greater than equal to negative 25. So it always comes from that vertex. So the range always comes from the vertex, the y, the vertex. It's either greater than that number or it's less than that number, whether it's opening up or down. Yeah. I'm going to show you this, okay? Domains. Now, there's different ways you can write domain, okay? So, this is pretty standard, okay? Another way you can write domain is in what they call interval notation. Okay? I just want to show it to you. Okay? If it makes sense and you want to use it, you can use it. Okay? You can just write it just like this. All real numbers, y greater than negative 25. Okay? Interval notation. So what is interval notation? Well, it uses brackets, okay, for numbers that are not included. Okay? Or no, numbers that are included. It uses parentheses for numbers not included. So when we look at all real numbers for our domain, okay, we're including every single number. Okay? So we're going to go from negative infinity all the way to positive infinity. Okay? Now, can infinity be included? No, because infinity is not a real number concept. Okay? Because if you say infinity, I can say what? Infinity plus 1. Right? So this is not a real number, it's not really included, so this is going to be parentheses around them. Okay? Because that actual is not an actual number being included. Okay? Now my range. In this case, we have y greater than equal to negative 25. I'm starting at negative 25, and I'm going up forever, all the way up to infinity. Again, infinity is not included. Is 25 included? Yes. So it's going to get a bracket on that side. Okay? So you can have both sets of parentheses because neither number is included. In this case, with these, you'll always have one bracket and one parenthesis because it's either opening up forever or it's opening down forever. Okay? So that's just interval notation again. If that makes sense, you want to use it, that's fine. You don't have to use it. Okay? You can write them just like that, and those are what we'll kind of look at. Okay? So let's do this last problem here together. Okay? So in the second one, part B, where'd it go? There we go. All right. Does it open up or down? So it opens down. Okay. So maximum or minimum? Max. Okay. So again, how do I find that? How do I find that max? What do I need to find? Vertex, right? So I need to find that x equals opposite of b over 2a. Opposite of b is what? Negative 2. 2 times a is negative 1. So negative 2 over negative 2, which is just positive 1. Okay. So now I need to find the y value, right? So what do I do with that 1? Plug it in. Be careful. Only the 1 gets squared. Okay? Don't square that negative in front. So 1 squared is 1, becomes negative. 2 times 1 is 2, plus 3. So negative 1 plus 2 is 1, plus 3 is 4. So my vertex is 1, 4, right? And so then my domain, what's my domain? All real numbers. Okay, or you can say negative infinity, oops, to positive infinity, right? So if you go into like calculus, you'll probably use interval notation for pre-calc. Range. Y values, right? And this is opening down, so y is less than or equal to 4. Okay, so again, interval notation, you can say negative infinity all the way up to 4, and 4 is included, so that bracket. Okay, so again, you can use either one of these, I'm fine with. Okay, so really everything was from yesterday except for domain and range. Okay, domain's always all real numbers. Range, it's always greater than the y value of the vertex or less than, based on if it's opening up or down. All right?